We've been working with slope all the way back to middle school. So we're just going to do a quick review here. We're going to do this. You can use a whiteboard to do this just to make sure you've got it. We're going to talk about slope as a rate of change, a rate of change. So when we're talking about real world application, this 25, which is your slope, has a meaning. It is the change in y over the change in x. So you've got your change in y over your change in x, and your change in y reflects a quantity of a certain kind. Your change in x is a difference in x of a certain kind. So it's a quantity that has a label to it. So change in y over change in x. In this case, our change in y is going to be the change in cost, which is in dollars. And the change in x is going to be the change in the number of units. So 25 would be $25 per 1 unit. That's your rate of change. $25 for every unit. Now they further go in to tell you what that $25 per unit means. So the slope of m equals 25 tells you that the cost of producing each unit, the cost of producing each unit is $25. So they call that the marginal cost. If the production increases by 1 unit, then the margin or the extra amount of cost is $25. So if it's $25 per unit to produce 50 units, then if I produce 51, I have an additional amount cost of $25. Seems like a very simple concept, and it is. We're going to talk about marginal cost again when we work with derivatives. So it's very important that you understand our marginal cost right now is our slope. So our marginal cost is our slope. Let's use whiteboards to make sure that we know how to find the slope. So grab your whiteboard and let's see if we can do this. So I've got y minus y, negative 14 plus 11, negative 15 minus 5. I'm getting negative 3 over negative 20. I got 3 over 20. If I'm going too fast, press pause. Okay, the slope for the next one, change in y. Now, my brain is already starting to go wacky here, so I'm going to say negative 15 minus 5, negative 3 minus a negative 14, negative 20 over 11. And when I have a fraction that's negative, I write, in handwriting, I write the negative in the numerator, negative 20 over 11. So hopefully I did not make a mistake. If I did, I'm sure someone's going to call me on it, which is a good thing. Okay, write the slope-intercept form of the equation, slope-intercept form of the equation of the line through the given points. So go ahead and see if you can do that. Press pause, come back. If you can't and you need a refresher, I'm going to do that right now. Negative 3, negative 1. I'm going to find the slope first. So my slope is 2 minus negative 1, 4 minus negative 3, that's 3/7. And then I've got y equals mx plus b. I'm going to do this in a different way. So y, let's use this point right here, is negative 1. The slope is 3/7. X is negative 3 plus b. Negative 1 equals negative 9/7 plus b. Multiply everything by 7. Negative 7 equals negative 9 plus 7b. Add 9. I get 2 equals 7b. b is equal to 2/7. Just feels like it would have been easier another way. Y equals 3/7 x plus 2/7. So that's our slope-intercept form. I'm going to check, just because this isn't the way I normally do this. I would normally do y plus 1 equals 3/7 times x plus 3. I'd multiply everything by 7. Then I'd distribute the 3. And I would subtract 7y equals 3x plus 2, and then I would divide by 7, and I would get the same thing. Cool. Cool, cool, cool. Okay, write the standard form of the equation. So the standard form of the equation is ax plus by equals c. So through 0, -5, and 3, 0. Still going to start off with my slope. So the slope is equal to -5 minus 0 over 0 minus 3. That's going to be positive 5/3. This is my y-intercept. So I've got y equals 5/3 x minus 5. And now I'm going to multiply everything by 3 to get this into standard form. I'm going to subtract the 5x. Some textbooks will allow this to be an answer, and some textbooks are going to want you to lead off with a positive. So either one of these could be a correct answer.